The history of Unix graphics systems goes back to the 1984. MIT Athena education project. Athena was not a research project, and the development of new models of computing was not primary objective of the project. Indeed, quite the opposite was true. MIT wanted a high-quality computing environment for education. In collaboration with DEC and IBM, the project developed a platform-independent system to link together different systems from multiple vendors through a protocol that can both run local and remote applications. This system was the basis of the X Windows system, which began its growth in 1985 and was ported for various Unix and not just Unix platforms. We now have several successors to the classic X Windows system, the most famous being the Android on mobile devices or Wayland graphic system on Linux desktops, but X Windows system is still widely used today. And we will discuss some non-trivial concepts related to this. To see them, just look into manual page. First of all, the X Windows system is a network-oriented client-server architecture. But the relationship between the client and the server does not seem very clear at the first glance. Generally, the X server simply accepts requests from various client programs to display graphics, application windows, and sends back user input from keyboard, mouse, or touch screen, and the server, for example, will run on your tablet, and the applications that run on the supercomputer are just clients. The main principle of X Window provides mechanism rather than policy. In particular, place user interface policy in the client's hands. And the main locator for the X server is the display environment variable. Display consists from host name, display number, and screen number. Host name is optional. Its absence means localhost. The display number is a unique identifier for this X server and should always appear in the display specification. And the screen number is an optional parameter for multi-screen X server configuration. Let's try to play with this. First, we will switch to another virtual console. For example, to send one by Ctrl Alt F2. Actually, in Linux, we have 12 virtual consoles by number of function keys on keyboard. And we can switch between them using Ctrl Alt function key. In some of them, we see a login prompt and can log in here. Now let's run X server. So we got an error, and this is expected. We already have a running X server in the system, which occupies a zero display. This is not a problem. Let's try to run it on the next display. Okay, it looks like a black screen without any graphics element. Something is wrong? Oh no. On the fourth virtual screen, log in again and set the display variable. Now let's start the good old terminal interface, the Xterm application. Okay, let's go to the third virtual console where we left our X server. Great, we see the terminal, but this is strange. We can only print something while staying in the terminal window. We can't move or resize it. Moreover, we don't have a button to destroy it. It's just because we have a system developed on the KISS paradigm. Xterm just emulates a terminal. If we want to move or resize windows, for example, we don't need this for information kiosk. We need a special program for this, a window manager. Let's try it on Xterm by starting one of the graphical user environment, GNOME. Okay, we now have a fully functional graphical user system in which we can work with graphical applications in the usual ways. Another important thing is geometry. Geometry we can set by setting the width, height, and shift to X and Y axis. With this parameter, we can set the position and size of application window. Finally, we by this way. As we can see, we got two Xterms with different geometries. And finally, we can choose colors for applications that support such settings. X Windows supports the use of abstract color names as described in the configuration file. It supports the use of abstract color names as described in the configuration file USRC X11 RGB TXT. In this file we can see the red, green and blue values for the named color definitions. Another non-trivial point is fonts. Xwindow supports both bitmaps and scalable fonts. In the latter case, it's possible to use so-called font servers to remotely render scalable font to bitmap, which was used for low-level X terminals. Classic Xwindow fonts are handled by utilities, Xfontcell, XFD, XLS fonts, for example. In the font specification, we see the manufacturer's name, type, variety, size, resolution, encoding, and so on. Fonts names tend to be fairly long as they contain all the information need to uniquely identify individual fonts. However, the X server supports wildcarding of font names, so the full specification. This is good, but not good enough for the modern WYSIWYG world. The standard Xwindow paradigm knows nothing about presentation on paper, only on screen. All documents are executed by applications creating PostScript language output for high-quality printing. And with the widespread distribution of Office suites, this paradigm turns out to be insufficient. For the modern WYSIWYG graphical interfaces, a new font engine has been developed, FontConfig, which works with PostScript and TrueType fonts and processed by utilities FCCache, FCList, FCCat, FCMatch. Classic Xwindow applications are built using the Xtoolkit library and generally support a standard set of options. The most commonly used display, name of the X server to use, geometry, initial size and location of the window, title, window title, background, foreground, colors for window, font to use for displaying text and some resources related options, name under which resources for the application should be found, and XRM resource name and value to override any defaults. What is it? Xwindow resources. They described in the manual pages for Xwindow applications and can be used to customize the default settings for Xwindow applications. Resources must be located in .xdefaults or xresource file in the home directory and can be processed by XRDB utility or on the fly. The description looks like this: object, sub-object, attribute, value. And in Xwindow, the object-oriented paradigm was implemented even before it was implemented in well-known programming languages. Program components are named in a hierarchical fashion, with each node in the hierarchy identified by a class and an instance name. At the top level is the class and the instance name of the application itself. By convention, the class name of the application is the same as the program name, but with the first letter capitalized. Some examples of resources. GNOME user interface uses its own resource management, jconf, and tools for working with it. jconf editor and jconf tool